Hello everyone, welcome back to my channel of Pharmacy. So this is the video about HLB scale. So generally what is HLB scale? So it is defined as the hydrophilic and lipophilic balance. So what is hydrophilic and lipophilic? So first of all we should know hydrophilic means which is water loving and lipophilic means which is oil loving. So if hydrophilic is a water loving, then it is an hating of oil, and lipophilic is an oil loving, so it is an hating of water. Okay, so these are quite opposite. So this is the scale which gives the relative comparison between the hydrophilic portion of the non-ionic surfactant with respect to the lipophilic. Okay, so this is the definition of the HLB scale, and this was first discovered by the Griffin in the year 1954. And here when the hydrophilic nature increases, then the HLB scale value also increases, and when it comes to the lipophilic nature increases, the HLB value also decreases. Means if HLB value increases, then it is more hydrophilic. If HLB value decreases, then it is more lipophilic. So this is completely of HLB scale introduction. So here, why we choose this? Because we have to identify whether what is the property of the surfactant it is exhibiting. So here there is an scale representation. So one of the most important one. So this is the complete pictorial representation of HLB scale. Uh, Looking is thing you think that is difficult, but when we learn it would be so easy. So here HLB scales consist from 0 to 20, that is readings. So we know that if the values are less, then it is less hydrophilic. If the values of HLB scale is more, then it is more hydrophilic. So got the point. So here 3 is an anti-foaming agent. Means when we take in an agent, if it is exhibiting its HLB value in between 0 to 3, I mean 1 to 3, it is anti-foaming agent. And when it comes to 3 to 8, it is water in oil emulsion. And when it comes to next 7 to 9, it is wetting agent as well as spreading agent. And when it comes to 8 to 16, it is oil in water emulsion. And here 13 to 16 is detergents, and finally 16 to 19 and 20 is an solubilizing agent. So definitely you should remember, not only here, in your entire life we should remember what is the HLB scale and what are the values of HLB scale. So first of all, it is little bit confusion, but we can solve this. See, first we have to reduce the foaming, so we will use anti-foaming agent, that is 1 to 3. And after reducing anti-foaming agent, we have to adjust whether, okay, selection of which emulsion. So water in oil emulsion means oil is an continuous phase, whereas water is an dispersed phase. So here wetting agents are next, which increases the wettability of the specific agent. So that is from 7 to 9. And also spreading agent the same. And oil in water emulsion, that is more quantity of water which is continuous phase, and less quantity, that is oil, which is the dispersed phase. And next detergents, and next solubilizing agents. So this is while you are writing, just you have to explain what is solubilizing agent, what is detergent, what is oil in water emulsions, anti-foaming agents. Then it would be too good. Okay, here I gave some information regarding this. So here solubilizing agent, name itself indicating that which increases the solubility, okay, of the particular solvent. These are the surfactants which increases the solubility of one in another. Means the one is having the more solubility range, and which can also increase the others. So these agents are called as solubilizing agents. Example: acetone, ether, chloroform. And detergents. Detergents are a group of compounds with an amphiphilic, see here, amphiphilic structure where each molecule has a hydrophilic, that is polar head, and long hydrophobic, that is tail, that is hatred of water. And here this is the structure. Amphiphilic means it consists of both hydrophilic as well as hydrophobic. See, the head nature is hydrophilic, loving of water, and the hydrophobic tail, which is hated of water. And the hydrophobic tail may be of straight or branched chain hydrocarbons, that is HC. And you know, these detergents have the ability to reduce the surface tension. Examples: deoxycholic acid and SLS, sodium lauryl sulfate. Mostly we use the sodium lauryl sulfate as a detergent to reduce the surface tension. And next water in oil emulsions. So we already learned that water, whenever the oil is present at the upper portion, that is in numerator position, we should indicate that oil is the dispersed phase, and whenever it is present in the here see, water is present in the denominator position, so then we have to say that water is the continuous medium, remember. So now milk is an example of water, oil in water emulsion. Why? Because while you considered milk, milk is completely of water, like its nature. In rest of that milk you can find some fatty particles, right, like oil particles. So those are of less quantity in the higher quantity of water like milk. So that's why we taken milk as an example of oil in water emulsion. When it comes to water in oil emulsion, so remember, water in oil is having the low HLB value, whereas oil in water is having the more HLB value. Okay, now butter is an example of water in oil emulsion, because see here, emulsion, butter which is so greasy, so here we use the oil has the more quantity when compared to the water. And next, wetting agents, name itself indicating that every agent which we take in should need the wetting, right? So the wetting agents, also called as surfactants, means a chemical substance that can increase the spreading and the penetration property of a liquid by lowering its surface tension. Means its activity is to reduce the surface tension by increasing the spreading and as well as penetration. So spreading means completely distribution throughout the liquid medium, and penetration means it should have the capability to enter. And examples: gum arabic, oxygal, and alcohols. Here mainly how we can say whether it is having a more wetting nature or less wetting nature or no wetting nature. So remember, here we calculate them instead of contact angle. Means remember here, wettability is inversely proportional to the contact angle. Means if contact angle increases, wettability decreases. If contact angle decreases, wettability increases. Remember, contact angle is nothing but the particle which can completely should dissolve in the water medium. So when it completely dissolves in the water medium, it should have the contact angle that is 0, that is less than 90. Then we can say it is inversely proportional to wettability. So it is directly proportional to wettability because contact angle is less, right? And when it comes to contact angle 90, it is wetting or it is poor in wetting. But when it comes to contact angle which is 180, which is greater than 0, so it is non-wetting, means it's not having the ability to wet in the liquid. So what is contact angle? It is an angle formed by a liquid at three-phase boundary where a liquid, gas and solid intersect. Okay, at the same position where all can intersect. Remember, where the liquid can form an angle. So you have heard of Young's formula, right? So this is the Young's formula. The symbol which is looking like the R is not R. It's the structure of bending position. It is called surface tension. So surface tension SV plus surface tension RS LS plus surface tension LV cos theta. So here theta is of contact angle and the symbol indicates surface tension, and SV is the contact angle between solid and vapor surface free energy, and S is the solid surface free energy. Surface tension L means liquid surface tension. So if you observe this diagram, see this is surface tension SV, that is surface free energy, solid surface free energy, and this is liquid free energy, and this is the angle theta, and this portion is having only wettability, not of this portion, and this is the liquid, and this is completely of this video. And if you have any doubts, so please comment. Thank you.